All right, we are now recording. Welcome everybody to our fourth guest SME session for our Unmanned Systems Graduate Speaker Series. I have the extreme pleasure today to introduce Mr. Paul McDuffie, who is the Director of Regulatory Policy and Operations Analyst for Hyundai Motor Groups' new Air Mobility Division. Paul serves as the advisor to Hyundai on matters that relate to regulation and policy for air mobility operations. His involvement in air mobility development is extensive. Prior to joining Hyundai, he served as the regulatory advisor to Boeing's Horizon X division. Prior to that, he held the position of Vice President of Government Relations for Insitu, and he was responsible for driving much of the company's efforts transitioning into commercial and civil market opportunities for unmanned aircraft. Prior to his time at Insitu in 2006, he transitioned from a 30-year career in academia as a full professor, the chief pilot and instructor, and vice president of aviation training here at Embry Riddle Aeronautical University at our Daytona Beach campus. He served on the AUVSI committee and past member of the FAA UAS Aviation Rulemaking Committee, or the ARC, as well as the UAS Remote ID and Tracking Rulemaking Committee. He's a past working chair on ASTM's F-38 committee, developing industry consensus standards for small UAS. Paul also served 2 terms as the chair of the Aeronautical Industries Association UAS committee. He recently completed a 7-year term as co-chair of the RTCA Special Committee 228, chartered by the FAA to establish performance standards for UAS command and control, as well as detect and avoid solutions. Paul was awarded the RTCA 2017 Achievement Award and Outstanding Leader Award. He's a former member of the Unmanned Aircraft System Team Steering Committee and was a member of the National Academy of Sciences, Engineering, and Medicine UAS Risk Assessment and Urban Air Mobility Study Panels. Besides this amazing list of accomplishments, I've had the pleasure of serving with Paul together on the NBAA Emerging Technology Committee that he co-chairs. We've also had opportunity to sit on a number of the same industry panels and presentations over the last few years. Of course, the one thing that I am absolutely most proud of is that Paul wrote the foreword to my book, The Small Unmanned Aircraft Systems Guide. So you guys hear me harp about this all the time. Paul, just a note, this book is available completely for free to Embry Riddle students through our Hunt library. They can access it in e-form, so they can read your amazing words. So with that, I would like to introduce Mr. Paul McDuffie.
Wow, Brent, I don't know who that guy is, but it doesn't sound like me. I should be dead after all that, but I appreciate it. I really do. It's been great working with you, over the years, and glad we're there to make a difference. So I appreciate the chance to speak with you all tonight. It's kind of different for me. As Brent says, I've had kind of a wide and varied career. The last 15 years or so have really been spent in this unmanned aviation world. I guess unmanned is probably not the most accurate description anymore, because I've kind of transitioned into the next step. I've evolved and are now kind of working what would be the logical next step, is taking what we have all learned and gathered from our experience with traditional unmanned systems and trying to transfer what we've learned into kind of the next modality for aviation transportation. That's advanced air mobility, UAM, whatever term you want to use works with me. I like AAM. The term AAM actually evolved from some work that I did again with the National Academies of Science about 2 years ago. We wrote an AAM roadmap or a blueprint for NASA, and the small group of a lot smarter people than me, we basically came up with the AAM term, which seems to be sticking now because it does encompass an awful lot. I'll talk a little bit about the blueprint. I'll tell you that it's something that, from a reference document standpoint, it's something you might want to grab onto. It'll kind of give you some more perspective on some of the things we'll touch on tonight as we go through this. So what I was kind of hoping to do is kind of give you a little bit of background, tell you about the kinds of things that keep those of us who are in the advanced air mobility world up at night, kind of look at where AAM is today and what kinds of things we need to do to really advance this agenda going forward. A lot of information in the news. I'm sure you've read a lot of it. You've seen a lot of it. I don't know how many presentations and symposiums and conferences I've been to that somebody doesn't get up there and shows pictures of the George Jetson flying machines out there. Our world is inundated with lots of PowerPoint presentations. There's about 230 different AAM variants out there right now. Everybody has the solution, and if you don't believe it, just ask them. But the reality of it is we're still kind of a ways away from having something that is truly effective and something that's going to be sustainable and scalable going forward. Lots to do in this space. As I said earlier, we are learning an awful lot from what the traditional small and mid-size UAS community has learned. We're transitioning and integrating an awful lot of the technology and the kinds of operational elements into the design and approval for AAM ops going forward. AAM is going to rely very, very much on autonomy, high levels of autonomy, high levels of automation. We have to have that or we're not going to be viable. People are expensive. The only way advanced air mobility is going to be scalable in the future is if we can reduce the human footprint as much as possible. We've seen that done with UAS. We have to kind of keep that mindset in the forefront as we talk about AAM going forward. The only way AAM is going to survive is through real high volume operations in relatively complex airspace environments. That in itself poses a problem, and we'll talk a little more about that as we go forward. So as I said, there's a lot of things that have helped my hair turn the color that it is. Much of that came through my UAS involvement earlier, and it continues on now in the AAM world. I'm lucky enough to be working with a group of people at Hyundai who are taking a very measured, incremental, and intelligent approach to developing these vehicles. They're not starting with a PowerPoint presentation and working backwards. We're really taking this thing, in the right direction. So, one of the things that they brought me on for was really to kind of ground them. We have an awful lot of people in the company who came from Bell Helicopter. They're traditional engineering kinds of backgrounds. Many of them have no aviation experience. Of course, Hyundai is a car company. This is kind of new territory for them. So, it's really providing an opportunity to build something from scratch and do it right the first time. So we're taking our time with this thing and looking at all of the different angles and issues that surround developing an AAM platform. And we'll talk about some of that. So one of the things that Brett's aware of is, and as he said in the intro, I've been working for the last couple of years with NBAA, National Business Aviation Association, and their Emerging Technologies Committee. And one of the things that I'm privy to is some of the inner workings and thinking of the business aviation group in terms of what their strategic plan looks like. One of the meetings I sat through a couple of weeks ago was a thing called their strategic focus team. And during that meeting, they laid out kind of their strategic vision of where they want to take the association going forward. I was particularly excited by the fact that NBAA which is a significant organization, has really embraced the idea of advancing AAM technology. Most, if not all, of their strategic plan really aligns very nicely with the strategic targets that most of the AAM industry is wrestling with, and there's 5 of them, and I want to kind of go through each of those in some detail with you guys tonight, so you can have some perspective of the kinds of things that need to be addressed going forward. So the 5 of them are, and they're all fairly obvious. Safety. Safety is always the number one concern whenever you have a conversation about this. Any organization, any manufacturer, training organization, operations, service provider, whatever, safety is always the number one priority, and that's no exception in the AAM world. I kind of add a number of other elements to safety, and what we'll talk about that. Security kind of goes hand in hand with that, and there's a security element to all of this that we have to address going forward. You heard Brett mention well, maybe he didn't. He was before the meeting started, but infrastructure is kind of the second element. There is no viable infrastructure in place at this point to support AAM. It's coming, and we'll go into some more of the detail on that. Sustainability is the third one. We'll go into it. Innovation, clearly, we're in a mode now where innovation is key to this, and there's a lot of fertile ground out there for us to jump into the innovation elements of this. And the fifth one, and the one that's really kind of interesting, is workforce development. Workforce, the whole workforce issue is a real serious threat to the development of AAM going forward, and we'll talk about that a little bit in some detail. So, if you will, let me backtrack and talk about the safety and security issue. I look at safety as being a priority rather selfishly. If you think about what an air mobility vehicle will be, it is another air vehicle that will likely transport property and people for compensation and hire. If we are going to carry passengers, okay, in a passenger carrying air transportation mode, which is exactly what the vision is for AAM going forward, there would be a clear expectation on the part of the public that they are going to involve themselves with a vehicle that is as safe, if not more safe, than anything else they put their carcass into. This is to them an extension of their trip, either a business trip or a vacation trip or whatever, or simply cross-town transportation. But the expectation is whatever they involve themselves with is going to be as safe as any other mode of transportation that they fly in. So we're looking at this as others in the industry as an opportunity to build a new class of air vehicle to the same design and certification standards as any traditional aircraft going forward. We're looking at Part 23, which is kind of the standard airworthiness certification requirement for traditional aircraft. We know that a lot of the UAS, because the actual certification criteria for UAS is not clear, so they were following the 2117 kind of model. I'm just not sure that's going to be publicly acceptable. Having an air vehicle that is certified as a special vehicle or under special class probably isn't going to sit very well. So, the thinking is that we are going to certify to the same standards as any other commercially produced air vehicle going forward. So much time and effort is being spent by the industry on getting a vehicle certificated, type certificated, and I'm not going to try to diminish the complexity associated with that. But one of the other elements that we have to look at, and again, there's great safety ramifications there, is the attainment of operational approval. Getting the opportunity to operate these vehicles once type certificated is a real long pole in the tent. We are looking at integrating a new class or new category of air vehicle into an airspace environment that was really never designed to accommodate it. We mentioned earlier that success in AAM is going to be largely dependent on high volume operations. We're going to put a lot of these things in the air at the same time, and operating in places that are rather complicated. We're talking about major metropolitan areas, in and around major airports. Significant challenge for the airspace management aspects of this, and do it safely, so that we don't put the public at risk, we don't put legacy operators in the airspace at risk, we don't put people on the ground at risk. So an entirely new approach to airspace management is clearly on the table. And we're looking at a number of different elements and ways to do that. But we could spend another hour and a half talking about that specifically. So I'm not going to belabor it, but it is a significant issue. If we're going to conform with kind of a generic concept of operations, we've got to make some changes in how these vehicles are managed, in that airspace environment going forward. So, we'll leave that now. And I want to talk a little bit about infrastructure. There's a lot of talk now about infrastructure. It's I guess stalled out in Congress. There's been a lot of effort on the part of many of the trade associations, certainly NBAA, to try to look at obtaining grants for developing infrastructure to support the advancement of AAM. Doesn't look like that's going to get anywhere this year. Doesn't appear that Congress has an appetite for doing any additional funding for aviation related areas in this package. So we're going to keep up the good fight. But from an infrastructure, my God, there's a lot that's needed here. We're talking about operating these vehicles to and from non-traditional places. You're not looking at an AAM environment that is limited to operating from existing airports. You're talking about providing air services from non-traditional places. We're talking about vehicles that are, for the most part, eVTOL or vertical takeoff and landing capable. So a whole new infrastructure, a whole new ecosystem has to be developed to support that new class of vehicles. So we're talking about building vertiports. This may be new construction, and at strategic locations in most of these major metropolitan cities. One of the things, if you read this advanced air mobility blueprint that we put together for the national academies, one of the sections that I was involved in was looking at this infrastructure component. And one of the things we're looking at is the possibility or probability of repurposing existing infrastructure / real estate to serve the AAM community. We're looking at abandoned shopping malls, large tract real estate, places that are in, from a public standpoint, very optimal locations. Could these places be converted to, AAM kind of support infrastructure? I think they probably could. So, we're looking at that sort of thing. The locations for these vertiports and vertistops, obviously very critical from a strategic standpoint. We have to examine the availability of a ground infrastructure to get people to and from the vertiport. So there's clearly a link there. We have to consider the micro weather. We're talking about air vehicles that are operating at relatively low altitudes in the potential urban canyon kind of environment around tall buildings and structures, all of which could greatly affect the operation of the vehicle going forward. The ability to observe weather, have accurate observations and have those observations integrated into a strategic plan, a flight plan, a strategic kind of operational environment so we can, operate these vehicles, very critical. Again, no infrastructure in place to do that. So that's a concern. The nuisance factor, noise. A lot of these companies now are taking kind of a scenario specific approach to deciding where they're going to operate. They're looking at these cities, looking at potential locations to, depart and arrive to, what kind of service they want to provide. As we mentioned earlier, there's going to need to be a change in the way we manage air traffic. One of the things that comes up pretty regularly is the need for performance-based navigation with these vehicles. It's pretty well agreed at this point that we're not talking about operating AAM vehicles randomly or essentially picking people up from their front yards and taking them to the neighbor's place 20 miles away. We're talking about operations that are probably going to be in fixed route structures of some sort. They may or may not be charted, but they will be very specifically defined, waypoint defined, and will require extremely accurate navigation of these vehicles so that we can strategically separate them without overburdening the current air traffic system. One of the major tenets that most of us in this industry have is that we want to try to do this. We want to try to integrate these vehicles into the airspace without overtaxing the stakeholder community, which includes air traffic control. Now, I spent a lot of time talking with FAA folks, and I've given talks to the Air Traffic Controllers Association, and all these guys, they're great. They all say, "Oh, wow, we really think this air mobility thing is really cool, and we'll be there to help you just as long as you don't increase our workload." I can understand that. So we've got to get pretty creative, from an infrastructure standpoint, and I consider the airspace management component part of that infrastructure. We got to be creative, and it's going to require, very specific performance-based navigation to make it work. With that, you increase the risk of being a real nuisance to the people underneath these routes. I look at, PBN, R&P. It's kind of like building a railroad tracks over your house. The accuracy and navigation will put, a continual stream of vehicles over a single location over and over again. So, unless these vehicles are super quiet, or flown over areas where, the nuisance factor is minimized, we have a real threat to public acceptance. So, as part of the overall effort, we've got to be kind of cognizant of that and move forward with it, smartly.
So this is, sorry, I didn't mean to interrupt, but this is an opportunity really for us to look at similar efforts in the past of rotary wing. What happened in the 60s, 70s with the advanced push for urban helicopter operations.
Right.
We can now look at the lessons learned there. And I think the piece I'm hearing is the path forward, at least initially, is sustainable, routine, scheduled operations that are very consistent with modern aviation as we know it. Less ad hoc and more clearly connected and supportable.
Yeah, that's spot on, Brent. Yeah, you absolutely got it. These are going to be scheduled operations. Everybody's thinking in terms of a Part 135 like operation, but you're right. I mean, they're not going to be operated in segregated airspace per se, but they will operate in the same airspace shared with others, but on very fixed and well-defined routes. So that, and yeah, they're like the helicopter routes, all of which or most of which are charted. I'm not sure how much from an navigation accuracy standpoint they're actually followed, but they're there. So yeah, it's very, very, very similar in overall concept. You're right. So, again, kind of continue on with the infrastructure concern. We've got obvious power grid, scenarios that need to be addressed. Electric propulsion is electric propulsion. Everybody's really concerned again with the throughput, the volume of activity that needs to take place. So we're really looking at a situation where charging opportunities for the batteries on these vehicles is pretty limited. There has to be relatively quick turnaround on it. If the volume of activity reaches what everybody's envisioning right now, it's not, the grids just don't support it. So again, that's, if there's anything that's going to keep you up at night, that's one of them, to try to figure out how that all works. And then of course, yeah, go ahead.
On that point, one of the things that came up, I was on the NASA FAA ConOps review that Deloitte put together. They one of the critical elements that came up with the city planners was prioritization, especially out west, where right now you have situations where you might have some brownout conditions because of over demand, overtaxing of the power grid. What happens when we introduce the vertiport? We have to remember these will most likely be considered critical infrastructure, especially if we start talking about them supporting, say, ambulance type work, which has been part of the discussion is, can they be provided in a disaster or a emergency response scenario? And if that's the case, prioritization of power needs to be established.
Absolutely. Yeah, I mean, it's an issue, and again, there are other nuances associated with delivery of the electricity to keep these things alive. Standards need to be developed, for charging stations. Something as simple as the actual plug that is inserted into the vehicle. I mean, I've seen 4 different suggestions for standards for those plugs, and no agreement on any of them. So yeah, it's going to be a fight. It's going to take some time, but clearly it's a concern. But I think there's going to be some solutions out there. Another area that a lot of people forget about is accessibility. These vehicles are going to be non-traditional. They are going to have some significant size, weight, and power limitations associated with them. They are relatively confined from an ergonomic standpoint. You can't have an AAM vehicle as big as a 737. I mean, these are 3-4 passenger vehicles at best, is the general configuration. The whole accessibility to people who are challenged in that respect, has to be incorporated into the design of the vehicle. The ability to carry, powered wheelchairs, things like that. Something that you don't normally think of when you hail an Uber, but certainly if you're going to take advantage of air mobility, you've got to consider that in the design of the vehicle. So, that's becoming more and more of a hot topic for those of us in the business. We can't forget that segment of the population. Pretty important. So again, that's kind of a quick brush over on the infrastructure aspects of it. Lots to it. I mean, it's one of those topics you could go on and on about. But I think you get the general idea that it's pretty significant. The third one was sustainability. Kind of goes without saying. These are vehicles that are certainly ripe for being sustainable from an eco-friendly standpoint. We're talking about electric propulsion, battery technologies, minimal impact on fossil fuels. All the things that are kind of the hot topics right now. This is obviously an important element into the future of AAM, and something that we're obviously very, very aware of. The fourth one rather was innovation. Good God, there's so much yet to be concocted to make this work. The whole idea of electric or hybrid propulsion, man, that's still a weak link in the chain. You know, battery technology is not where it needs to be yet. There are a lot of bombastic claims being made by some who are out there building vehicles and, you know, promising astounding performance. Good luck with that. I'm not convinced, nor is anybody on our team convinced that anyone has the complete solution just yet. You know, the whole eVTOL flight profile is challenging in itself. Vertical flight consumes tremendous amounts of power. You know, so you've got to transition away from, you know, that vertical mode to some kind of a horizontal, potentially wing-borne kind of mode, so that you can, you know, minimize your battery drain. There are limitations from an endurance standpoint. You know, how far can you go with these vehicles? You know, there are phenomenal claims about, you know, cruise airspeeds in the 150 to 200 knot range. Well, does it make sense to go that fast on a 30-mile trip? You know, I'm not 100% sure of that. So, you know, the battery technology issue is huge. You know, and it's, you know, it's potentially the real game changer here. So a lot of work to be done there.
Have you seen any discussion on it? I know a couple years ago we saw some mock-ups at base in Vegas for
Right.
NBAA, where there were groups looking at APUs, auxiliary power units, and kind of looking at more or less the Prius of the sky, if you will.
Yeah.
Is there an issue with that where it's not being pursued because maybe it's not incentivized on the government investment side, where we're being incentivized to move towards, as you mentioned, fossil fuel options, and hybrid it falls in the middle. It's not considered a solution.
Right. Right. No, there are two schools of thought. You know, there are some who are clearly, because of battery limitations, that, you know, a hybrid kind of solution seems to make the most sense. I'm probably one of those guys, and this is just me talking now. You know, I'm kind of in that camp. You know, if we want to get things rolling and get these things in the air, hybrid provides a near-term solution to the endurance and power requirement to get these things off the ground. So there is that. There are some who are concerned about the fact that, you know, hybrid is hybrid. It's not 100% electric. You know, it could again be into a fossil fuel powered, you know, regular kind of power plant to, you know, to generate the appropriate amount of power. Hydrogen fuel cell technology, you know, is kind of on the table. So yeah, Brett, I don't think anybody's got the full answer on that yet. I think everything is clearly on the table in terms of, you know, how we're going to operate these things, you know, in a scalable way going forward. Autonomy, you know, as I said earlier, this whole AAM concept is not going to work if we still have a significant human footprint. So we've got to move to high levels of automation, or full up autonomy. You know, which basically takes the pilot out of the vehicle. Yeah, I think that's the ultimate goal. Is that achievable in the next 10 years? I would say no. You know, I think we're going to have to evolve to that. I was in a meeting earlier today with the Flight Safety Foundation. I'm part of a ad hoc group kind of looking at autonomy definitions and looking at autonomy from a behavioral standpoint. You know, how do autonomous systems need to behave to support the AAM and the AAM community? And, you know, we're looking at about 5 or 6 different areas, anything from automated takeoffs and landings to automated detect and avoid, you know, and a number of different elements. You know, and everybody kind of realizes, you know, there's an awful lot of thought that needs to go into how do we evolve into a more autonomous world when it comes to AAM. So, again, from an innovation standpoint, that's pretty key, and we gotta keep working that piece.
I would argue that the autonomy that you expect to go with this to maintain really equivalent level of safety, it's probably the most complex autonomy task that we've got set out before us in aviation. And the reason I say that, I mean, if you look at just going in the ground systems where Tesla is operating and all the challenges they're having, that's only in 2 axes of operation. If you look at what we're doing or what we've done in, say, the commercial aviation realm, the volume of traffic is reduced. The complexity of operation is reduced. It's primarily fixed wing. So even the Z-axial movement is a lot less. So this is radical. I would argue probably the closest thing akin to it from an engineering perspective is what we've done for Mars missions. Because of that latency that exists, we have to program a high degree of autonomy in. So
yeah. Well, it's pretty clear that some, at least initially, some mixture of pure autonomy, in its purest form, to what I like to call a managed autonomy world, where you've got a human over or on the loop at some point, who can intercede when necessary. But incrementally, we will migrate away from that. Gamma's been working on SVO, simplified vehicle operations, now for quite some time, and that's the whole SVO concept is certainly one that gets integrated into into the design and operations of these vehicles going forward. So yeah, it's a tough one, and one we're all wrestling with. Communication, information sharing, is another area that's ripe for some innovation. We mentioned earlier that whatever we do from an air traffic management standpoint, it's not going to look like anything that currently exists. Any kind of simplex voice communication, either from a ground managed AAM operation to some kind of an air traffic role, we don't see voice being anything on as possible. So we're looking at what do we do with things like data link, be able to in a timely manner have a close tab on what the overall vehicle intent is as it operates in a trajectory-based kind of environment. All very critical elements to what will be a new way to manage the volume of vehicles that we're talking about. It's an entirely new approach to air traffic management. We're going to learn from the whole UTM discussion. I know you guys probably had discussions about UTM, and realizing that drones, UAS, kind of have been in that mode now for some time, operating at very low altitudes under 400 feet. We're talking about an AAM world that will be above the traditional UTM environment, but it's going to require an awareness, situational awareness of what that activity in the UTM world is, coupled with what we're doing in the AAM world, which will probably be at altitudes under 2,000 feet. So the whole communication, information sharing element of this is going to be pretty critical, probably more so on the tactical separation requirement of the new air traffic system as opposed to the strategic. But it is an element that is going to need some real work. And then ancillarily, we still have to look at this whole size, weight, and power issue. We've got to look at building materials that can be used to construct these aircraft, minimize weight, increase the structural integrity, be aware of the cost associated with it. We've gone a long way with composites and whatnot, but there's probably still more work to be done to find just the right mix for vehicles like this. So again, those are just quick off the top of my head thoughts from an innovation standpoint. I know you guys can probably think of a lot more. There's no wrong answer here. I think everybody's willing to listen to whatever suggestions come out. So the last one that I'll touch on is this whole workforce development. But we need smart people to make this work. Our company's drawing from all kinds of different sources to build our engineering team that'll actually design and build these systems. It's a challenge, but there are some good folks out there who are really interested in working with this. But we're building an ecosystem that is going to really require individuals who don't have traditional skill sets. This is a whole new world here. As we mentioned, one of the key elements to AAM is getting these vehicles certificated, and once they are, that creates certain requirements for the continuing airworthiness of the vehicle. You can't just, like your DJI drone, pull the instructions out of the box and it tells you how to change the rotor. That's not going to work, particularly on a vehicle that has a type certificate hung around its neck. So we're going to be out looking for technicians, individuals who can help with the maintenance of the airworthiness status of the vehicle that are completely non-traditional. Brent's aware that the NBAA Emerging Tech Group has been working with some of our members on this very issue. I'm working with some folks at Utah Valley State University on an organization called ATEC, which is the Aviation Technicians Education Council, to look at what is it going to take to produce individuals who are qualified to maintain these vehicles going forward. If you're aware of how aircraft technicians are born today, there's a set of regulations, Part 47, that or 147, that goes through certain requirements in order to obtain an airframe and power plant certificate. There's stuff in there like wood, dope, and fabric. Does that make a lot of sense for a vehicle like this? No, it does not. These are electrically propelled, entirely different flight control law scenarios, different power plant configurations that are not the traditional reciprocating engine, on and on and on. It's pretty obvious. This is like Captain Obvious. So, it's going to be obvious that we're going to have to change the way these technicians are produced and trained. And that's going to require, a very, very close working relationship, with the industry, with the manufacturers, and with the training organizations to create that pool, that network of individuals that we're going to need to sustain these things going forward. So again, pretty obvious. Pilots, we've already mentioned that, we're looking at vehicles that will initially have a pink body inside, being the pilot in command. We know the FAA at this point isn't interested in even talking about anything less than that. Their expectation that any vehicle or any operation that they approve or certificate, the assumption is that there will be a human on board the aircraft. So that's where we are for the foreseeable future. But with that comes, again, a new set of skills that are not traditional to manned aviation. I've been flying airplanes for 50 years, and there's virtually none of the skills that I've gained from 50 years that would transfer very well to an eVTOL AAM aircraft. I'd be lost. So, we're looking not only at changes in the way we produce the technicians that'll maintain these vehicles, but also the individuals who will fly them. And that skill set will evolve as well. As we move away from onboard pilots to remote pilots, a one-to-many kind of management where the pilot in command, who I don't believe will ever completely go away, may be based remotely what kind of knowledge, skills, and ability are going to be required to certify that individual, and make them a viable player in this whole AAM world. So the whole workforce thing is huge. You know, you folks, on this call are going to be key to helping us solve that. But it's clearly somewhere that we need to go. So I wanted to, before I lose my voice, I wanted to just kind of leave you with, a couple of suggestions. Brent and I were talking earlier about, where do you find the most contemporary information about the state of AAM? There are countless places that you can get a compilation of the latest news. I go to actually two of them. One of them is airmobilitynews.com. I don't know if you've seen that one. It's actually a European-based publisher who is really well tuned to what's going on globally from an AAM perspective. I mean, they know everything. A lot of the development of these vehicles is being done overseas. EASA, all the other regulators, around the world are wrestling with all the same things we just talked about. So urbanairmobilitynews.com kind of keeps you abreast on the progress of not only what's going on here in the States, but also around the world. There's another site called unmannedairspace.info. Talks specifically about the airspace integration elements of both AAM and UAS vehicles. I think it's actually produced by the same group that does Urban Air Mobility News, but they do a really good job of staying up on all of all the particulars. And then, finally, and I mentioned it earlier, if you can, get yourself a copy of this guy. I don't know if you can see it, but this is the National Academy's consensus study that we did a couple of years ago. It's called Advanced Air Mobility, a National Blueprint. It isn't the be all end all, but it was foundational to NASA's CONOP. There are a lot of pieces in that CONOP document that was birthed through this document, but it again touches upon an awful lot of the kind of stuff that I talked about tonight. I do know that the FAA is about to drop their own version of a CONOP. We've been waiting anxiously for that. We expect that to happen sometime in the next 30 days. Once that's out, I can tell you with virtual certainty that those of us in the industry are going to be looking at it from a regulatory compliance standpoint. And we'll probably undertake a fairly significant gap analysis, looking at existing rules, which ones can easily apply to the advancement of air mobility, and where new rulemaking needs to take place. It's going to be kind of an interesting project, there may very well be an outreach to some universities like Embry Riddle, to help with that process. So we know there's going to be some change needed in the existing rule set. We are all desperately trying to work within the current framework, simply because rulemaking takes a long time. Take it for somebody who, watched Part 107 come out of the ground. It took 10 years from the time we finished our ARC to the time the rule was actually published. So you can imagine when we're talking about, certifying electric propulsion, or a whole new air traffic control system, or the like, what that's going to take. So again, we're looking forward to seeing what that CONOP looks like, and see how we can apply it going forward. So I've talked way more than I wanted to. I will shut my trap, and if there's anything you guys want to talk about or any questions you think I can answer, I will do my best. And if I can't answer it, I'll find you an answer somehow or some way. So Brent, over to you, buddy.
Outstanding, Paul. Thank you so much. You've actually hit most of my questions that I was going to follow up with. I do want to hit you up with one more. You covered the 5 critical areas for AAM. What single technological advance or breakthrough do you find most exciting right now? What is the thing that you look at and go, wow, that's amazing, and it's such an accomplishment that we've been able to achieve this?
The one thing that I think will clearly apply to this is the auto landing capabilities, that Garmin came up with for manned aircraft. That technology clearly is applicable to AAM. Where the autopilots and the auto flight capabilities that now exist for traditional manned aircraft, that achievement, I think, has tremendous future potential for AAM vehicles. Where the whole AI, artificial intelligence aspects of the software and the hardware integrated into the Autoland capabilities, the ability to evaluate weather, to pick a contingency landing site, to configure the vehicle, to actually land the vehicle, to take care and handle all of the ATC communications, all without a human being being involved. That to me is pretty astounding. Like I say, if 25 years ago somebody told me that was going to be possible, I would have told them they were crazy. But it exists, and it's the kind of thing that is ultimately going to enable air mobility. And that's not all of it. I mean, we've got some slow advancements on automated DAA. That's probably the next most important thing. And we argued about that today. We took two areas that we wanted to dissect from a automation standpoint or autonomy aspect. One was autonomous takeoffs and landings, and the other was automated DAA. And as you know, there's a lot of fleas on that dog, Brent. Defining exactly what criteria are appropriate for detect and avoid. The whole definition of well clear. All of those piece parts that come with that. So, integrating, what is TCAS 2 or or the equivalent, into these vehicles. Again, those are between the landing, takeoff and landing, and the automated DAA. Those are two pretty critical elements. If we can conquer those two things reliably, at the right maturity level, we'll actually have something.
Outstanding. Well, with that, I'm gonna turn it over to my students here. I think Raquel was first, then we'll go, I think Steve Wells, then Juan, and Steven Stultz. So Raquel, go ahead. And
hi, Paul. Thank you so much for participating in this lecture. I have two questions. The first one is, how and what drove you to get on board with all the advisory boards, and what were some of the key takeaways from them?
That's a really good question. I have no good answer to it. A lot of them just kind of fell in my lap. There are lots of advisory boards out there. A lot of them that I got involved in, I was invited to join. I'm not exactly sure how, but one of the people that he's one of my mentors, and you may or may not, he's one of the former presidents of Embry Riddle. His name is Steve Slewa. You may have heard his name. Well, Steve and I worked very, very closely together in my 30 years at Embry Riddle. Our offices were right next to each other, and Steve is probably my best friend and one of the smartest guys I know. And one of his philosophies was, it's easy to make a living, but hard to make a difference. And that always kind of stuck with me. So I'd watch what was going on, and talk to a lot of people, and if not be afraid to give an opinion or to give a thought on a particular subject. And by doing that and being a little mouthy, people get to know you and build confidence in you, and you get an opportunity to engage in some of the things that I was fortunate enough to engage in. I'm an aeronautical science graduate. I'm not an engineer. I mean, a lot of this stuff I had to learn on my own. I mean, I'm an airplane driver, but you kind of evolve over time, and if you want to really make a difference, not just make bucks, you got to kind of stretch a little bit, and go a little bit out of your comfort zone, and that's what I did, and it kind of it allowed me to get involved in a lot of different things, and I'm thankful for that. So I don't know if that answers your question, but
Yes.
okay.
And my second question is, what advice would you give someone with an A&P and who's also a student pilot looking to transition into the advanced air mobility sector?
Just gather as much information on this, changing daily industry that you can, and then look at the companies that are developing these things. They're looking for enthusiasm, people who have an interest and a desire to do this, and everyone's hiring. Our company's hiring, all the others, Joby, there are countless other companies that are looking for talent, that people who are, passionate about this new technology. That you can be comforted in the fact that there's no one ahead of you. If you're a student pilot with an A&P certificate, that's just fine. I mean, there isn't, as I said earlier, there isn't a big bench of others who have more experience than that, who are entering into this segment. So no, I would encourage you to just not be shy. If you want to get into this segment and get into this business, call these companies, talk to these companies, send resumes. I think you're going to be surprised just how willing they are to accept you.
Thank you.
Sure.
Steve Wells.
How are you doing, sir? I appreciate your time tonight and your candor. You're one of the first people I met that's actually listed a lot of problems that are going on with adapting AM, such as you brought up, like just electricity and things like that most people don't think of. So my main question was, and this mainly comes from the Colonial Pipeline hacking attack that just happened. I know there a lot of research is going on how to secure the infrastructure, as you talked about with criteria-based encryption and other newer forms of data protection. Are they actually looking at even doing potentially like an intranet, a self-contained network for these systems? Because it seems every time they build on top of the previous systems, even if you secure 1,000 doors, there's 1,001, or there's another door that enables cybersecurity issues to attract to it. How in depth are they looking at that from the beginning? And is it even really in their mindset right now? Or are they just trying to solve the bigger issue problems and deal with it later?
Yeah, that's one of the gorillas in the room. I mean, everyone talks about cybersecurity, and how important the topic it is. But, I can honestly say I haven't seen a lot of attention given to it. I mean, right now, everybody's into the finding investors and doing pretty PowerPoints on a, sexy looking air vehicle. We know that the whole cybersecurity issue is out there, and obviously, from an overall safety perspective, it has to be addressed. We're talking about like you've suggested, secure networks that basically do all the data exchange required as part of the operation being integrated into the plan. I know it is from our perspective, and I know some of the others are also considering it. But I'll be honest with you, I don't think it has gotten the attention that it really requires. And there's another security related topic that I didn't talk about, and that's physical security. How do you secure the physical aspects of the operation, the passengers in the vehicle? We've had some discussions with TSA We're operating these vehicles out of, locations in the middle of cities, maybe transporting people to the air side of a major airport. How do you manage the TSA security elements of this? TSA has no idea. I listened to the director of TSA and he says, wow, that's really a big deal. I don't know how we're going to do that. So yeah, I mean, the whole security thing really is, it's another one of those elephants we're going to have to wrestle with.
No, I appreciate your answer. Oh, and for physical security, I used to be a Green Beret. So if you ever need a red cell team to test your methods, feel free to ask. And with that, if you wouldn't mind, do you have a LinkedIn or anything you could throw in the comment section? If you wouldn't mind doing that.
Yeah, I do.
Oh, awesome. Thank you.
Sure.
All right, I think Juan's next.
Hi, sir. Thank you for presenting tonight.
Sure.
I have a more general question. I was originally going to ask about cybersecurity, but you did a great job covering that. So my second question was, where are you seeing the biggest pushback for AAM? Like what sectors of the FAA, the private like concerned citizen groups, or where are you seeing the biggest pushback?
I don't know if anybody's really pushing back. Everybody's kind of excited about it. The only, if you want to use the term pushback, I think part of it is a little bit on the regulator side. They're enthusiastic about working with industry to certify vehicles. The biggest concern I have, though, is they are unwilling to address that whole rulemaking element that we talked about. A good buddy of mine is a guy named Bruce DeClean. He's the head of flight standards, and I was talking to him not long ago, and he made it pretty clear that the FAA's near-term plan is to operate on an exemption basis. That is, you present them with something you want done, they evaluate it, do a risk analysis on it, and then make a decision as to whether they will grant you an exemption to a particular rule, a special condition in your certification, whatever. Okay, that's one way of doing it, but if you're going to build these vehicles in the volumes that are going to be needed to have a sustainable and scalable business, you can't operate on a one-off exemption basis. So we've got to attack this whole regulatory side of it, particularly when it comes to certifying these vehicles and then obtaining that operational approval. Doing it on an exemption basis isn't going to cut it. So yeah, I think if ask me tomorrow, I may have a different answer for you, but my gut's telling me that it's that regulation, that rulemaking piece that could be a real stumbling block.
Awesome. Thank you, sir.
Sure.
All right, next, Stephen Stultz.
Yes, sir. How you doing?
Great.
Glad to have you with us. I appreciate you doing this for us. I have two quick questions. Hopefully they're quick. Maybe they're not. Number one, you did talk about manpower. You're talking about the crossover between the traditional like A&P and stuff like that. Do you not, I know you're talking about as from a flyer's perspective, as an operator, maybe not having those skills cross-utilized, but in the A&P world, I would think there would be a lot of cross-utilization. The second question is in relation to your NBAA webinar of the AAM sector. You talked about, I'm sorry, it's the, what was it called? I apologize. It's the one, it's a bird, it's a plane, building trust with building public trust.
Right.
All of these different companies that are working together, but they're not. All of these companies are working maybe in parallel, but they're not necessarily sharing data. Who and at what level do you think should be engaged in addressing who to gain this social awareness or public confidence, for lack of a better term? Sorry.
Yeah. There has to be very early in the game, and I frankly haven't personally observed a lot of this activity, but having early engagement with the public to discuss some of the detail of what's going to happen or what we'd like to happen is critical. There's a lot of misconception about this, and I think that having early engagement, at a not a highly technical level, but get specific in terms of how these vehicles will impact, hopefully in a positive way, the lives of the average citizen. A lot of the work is being done to develop concepts of operation based on specific operational scenarios. I think I mentioned that earlier. And it gets down to actually looking at notional routes, looking at notional service areas. If you can bring those ideas without exposing, individual company secure data, information, or whatever, but present that information to the general public, in a easily understood way, and get a dialogue started between the local communities and those of us in the segment, that will begin to erode. We hope will begin to erode that whole public confidence, that whole public concern aspect of it. I know our company is doing a lot of outreach now to some of the city managers, some of the local communities, to do just that. And so far it's been pretty productive. So that's key. And we got to do it as an industry. Just having one manufacturer do it probably isn't going to be effective. But if we can all rally around the same message and be consistent in its delivery, I think we'll accomplish what we need to from a public acceptance standpoint.
I think that's really what I was pushing for. Is you see like a Starkist tuna that's doing their own advertising, and you see Aquafina water doing their own advertising, whereas the beef industry, the industry is doing, what I'm saying. And so we are not doing that from what I've been able to see. And so you hit the nail on the head is what I was talking about, or what I was talking about there. The manpower coming from AMP was my second question, or my first one. So
yeah, I mean, there are some very competent airframe and power plant technicians, particularly those who are, really savvy on, avionics, the current high end of state of the art. And when it comes to traditional aircraft, we just need more of those people, and and shape the 147 curricula in such a way that you eliminate what some old geezer thought 50 years ago was appropriate to get an AMP license. And one of my latter jobs at Embry Riddle was to manage the aviation training component of the university, which encompassed not only the pilot training portion of it, but also the AMP school. This conversation we were having 25 years ago. I mean, this we could see this day coming. That how you train an airframe and power plant mechanic today, or even back 25 years ago, was inadequate to that it would require so much, kind of OJT, journeyman kind of training on the job, working for an MRO, or, under the auspices of a repair station or whatever, so that you could actually get the real skills to be effective in your job. Well, that costs your employer money and time. I mean, as a manufacturer of a vehicle like this, we want people who can step into the job, and legally maintain the vehicle in accordance to the type certificate requirements. And that is going to require very specialized skills and knowledge. And the place to focus on that is in the airframe power plant training from the beginning, from the ab initio. Yep.
Thank you so much.
Sure.
Outstanding. Juan, you have your hand raised. Did you have?
Sorry, I left it up.
Okay, I didn't know if you had a follow-up.
He just got
All
scared,
right.
that's all.
Well, outstanding, everybody. I really appreciate your engagement, and just remember to receive credit this week. You need to submit a brief discussion post-entry where you're going to briefly summarize the insight that you gained, specifically how the info that was shared supports your examination of unmanned systems evolution and advancement into the future. Make sure to discuss any info that you weren't previously familiar with and how your overall understanding of the topic might have changed. Also, feel free to share any resources that you find that help to connect this new insight to what's now happening in the field. Just so you're all aware, I highlighted and shared the info that Paul shared with us, including the National Academy's Consensus Study Report and the 2 websites that he uses to stay up to date. I put those in our Canvas Module 9 discussion area, so they're there, along with the NASA FAA UML Level 4 ConOps for advanced air mobility. So if you want to explore that topic, you got a plethora of material and resources at your fingertips for the next couple days. So once again, I really want to just thank Paul for joining us today and sharing your time, your expertise. This has been phenomenal. By the way, you mentioned 25 years ago you guys were having the conversation in Daytona. I'm just going to interject this. I was a freshman in Doolittle Hall 25 years ago to the day. So
There you go. Yeah, well, yeah, yeah, as I said, this is not that element is not a new topic. It's something we've fought over. We had the president of ATEC was the guy who ran the airframe and power plant school there in Daytona, a guy named Fred Merkel. He was just as frustrated as I am today, as I was 25 years ago, that we've got to evolve this stuff. And I think it'll come. I mean, there's clearly more and more interest on by groups like ATEC, that are really starting to get serious about it. And they've engaged with us at our emerging tech committee. NBAA is behind it. As I said, it's one of their strategic pillars. So everything's pointing in the right direction. Now we just got to get it done. That's all there is to it. So, hey, I appreciate this, guys. This was a lot of fun. And, Brent, you got my email. You can share it. I'm happy to, offline do anything I can to help you all get through whatever you need to get through. And hopefully we'll solve all these problems and make this a reality before I go to my happy hunting ground.
Outstanding. Thank you, Paul. Really do appreciate it.
Night all.
All right, thank you.
Thank you.